Alright, so in this video we're going to discuss the motion of charged particles in a magnetic field. So the cross is here a magnetic field, and our magnetic field is going into the board. So we're assuming a uniform magnetic field acting in the negative z direction. And my charged particle is given an initial velocity to the left. So we'll start up here. So in the negative x direction. So if I take my hand and I need to essentially flip it palm down, because then my fingers point to the left, and I curl my hand into the board to grab the magnetic field that's going in the negative z direction. So my fingers should touch the vector filled arrows going into the board. So my thumb points down, giving me a magnetic force down. So that magnetic force is tugging on the particle a little bit down, which causes it to end up in a circular motion pattern. So as we go around, we'll find that the magnetic force is always tugging towards the center of rotation, so the center of the circle. So this is very similar to radial motion we would have discussed in 151. Now this is assuming that the velocity, and the velocity comes from an outside source. When we do example problem, we'll discuss one of the sources of the velocity. And the magnetic field is perpendicular to each other. If they're not, you end up with a helical motion, which makes calculations a little more complicated. Alright, so we're assuming that our magnetic force here, and since I've made these perpendicular, I don't need a cross product here, is equal to mass times acceleration in the radial direction. So I plugged in mass, and then acceleration in the radial direction is v squared over r. So we learned this in 151. So I can rearrange this and solve and establish what the radius of this circle is based upon the mass of the particle, the speed of the particle, the charge of the particle, so that's an absolute value, and then the magnetic field strength. So often we can give a known speed and a known magnetic field, and we can use that to find the mass-to-charge ratio of a particular particle based upon the radius. And we're going to actually end up using this in our E over M lab to be able to establish the charge-to-mass ratio of an electron, which is called a specific charge.